And so grams, let's remember, grams tells us the mass of our substance, right? How much does it weigh? If we put it on a scale, we would get it in grams. Moles also tells us the amount of substance, but it's measured in a different way, right? Moles is a measure of quantity. So we know that 1 mole of any substance, let's review this a little bit. 1 mole of any substance is how many of that thing? Do you remember? 6.022 times 10 to the 23rd of that thing. So if I have half a mole, that means I have half that number of objects, right? Or how of that thing. Okay? So we need to remember that moles is kind of like dozen, but a lot bigger. All right, it's still an amount, a measure of quantity, of how much amount there is. It's just not really a measurable quantity for us, right? We can calculate it, we can count it, but it's not something we put on a scale or we measure that way, okay? So, we learned last time how to convert between grams and moles to grams using a T-chart system, right? The conversion factor between grams and moles, let's write this down extra. The conversion factor between grams and moles, or vice versa, is the molar mass. Okay, so what conversion factor is it? It's the way we are allowed to convert from one to the other. So if we want to go from grams to moles, we use the molar mass. If we want to go from moles to grams, we use the molar mass. Okay, that's our conversion factor. Okay. So let's look at this problem right up here. How many moles are in 74.2 grams of lithium chloride? We didn't do this one together, right? Okay. So we always start our T-chart with what we know. Good. 74.2 grams of LiCl. How is this problem different than the ones we had done in class previously? It's a compound, right? It's a compound. We had only done elements so far. It doesn't change anything about the way we solve it except that we have to calculate the molar mass first rather than just look at the periodic table. Okay? So let's go ahead and make our T-chart. We know we want to go from grams to moles, which we can just do in one step. So grams needs to go where? On the top or on the bottom? Grams goes on the bottom because here's grams. It needs to go diagonal from that. And I want to end up in moles of LiCl. Okay, we know that moles always gets the 1. Moles always gets the 1. And then we tell how many grams are in 1 mole of lithium chloride. Don't shout the number yet, but we're gonna figure that number out. Okay, so that right here needs to be the molar mass of LiCl, and so we have to calculate that. Okay, so if I come down here and I say LiCl, one of each of those molecules, lithium is 6.9. Chlorine is 35.5, which if I add those together, that gives me 42.4. If I can do mental math, 41.4? 40.5. Okay.
It's just, you don't round lithium as well.
You're right. I kept lithium at 6.9. And I kept chlorine at 35.5. That's what I got when I added those two numbers exactly. If you're somewhere in that ballpark, 42.3 or whatever, you're close enough. Okay, are we in agreement with that molar mass? So that's what number goes with grams. So 42.4. Now I check my units. I have canceled grams of lithium chloride. I'm left with moles of lithium chloride, which is what I want. So I do my math, multiply across the whole top, divide by the whole bottom. Should we be expecting more than 1 mole or less than 1 mole? More than 1 mole. How do we know that?
Because,
The amount we started with was greater than what 1 mole of that substance weighs. Right? A mole of the substance only weighs 42 grams, and we have 74. So that should tell you that we're going to end up with greater than 1 mole of substance. And I got 1.75 moles. Do we agree with that? So you need to be checking yourself to make sure your answer is reasonable. Right? Does your answer make sense? Yeah. Nope, significant figures and unit conversions, I don't use significant figures here. Okay? We need to check to make sure our answer is reasonable. We know what 1 mole of my substance weighs. We started with more than that, so we should end up with more than 1 mole. Okay? You need to be making sure that you didn't accidentally flip them, right? If your answer came out to be thousands of something, thousands of moles, that should be a red flag. Okay? How many grams are in 0.42 moles of that substance? We always start our chart with what we know. Moles to grams is 1 step. So if I need to get rid of moles, it needs to go on the bottom. Moles of MgNO3, 2. And I want to go to grams of MgNO3, 2. Does moles always go on, does the 1 always go on the top? No, where does the 1 always go with? Moles. Okay, and so what goes here with grams? Molar mass. Right, molar mass always goes with grams. So I want you to calculate molar mass of that compound, and we'll see if we match. End up with grams, and if I do the math, I should end up with, what, less than 75, 60 something? 60 what?
2.28. Do you have to put all that?
No, I would have rounded at 62.29 or 62.3,
Okay.
probably. That's fine. Yeah. We always want to make sure we label it with grams for sure, and I'd like for you to have the compound name after that as part of the unit. Okay, you have to have grams. It would be preferable if you have the compound name behind it as well. Okay. You ready to try the next 2 on your own before we move on to our next step, conversions? We're going to add to it today a couple different times. Okay, do the last 2 right here on your own. I've shown you Avogadro's number a couple times. Anyone remember what it is?
3.14.
No, that's pi. Avogadro's number helps us link the number of moles to the number of atoms.
6.022.
Yes, 6.022 times 10 to the 23rd. Okay, 6.022 times 10 to the 23rd is Avogadro's number. You will need to memorize that number. We will use it so much that it will, be burned into your brains, but until then, you need to memorize it. Okay, what Avogadro's number does is it allows us to link the number of items in 1 mole. And most commonly, we think about it as this is how many atoms are in 1 mole, or how many molecules are in 1 mole, but it could be baseballs in a mole, or any particle in 1 mole. Right? We've talked about Avogadro's number a couple times. It's like a dozen, but bigger. Get it? That's a mole. Oh my gosh. Get it? 1 mole equals this many things? Ha. Okay, whatever. Thanks. Thanks for ruining it. What do you get when you cut an avocado into 6 times 10 to the 23rd pieces? Guacamole.
Wait, you go back.
Yes. At least you got a little bit more genuine laugh there. I know. Hey! Okay, I'm done wasting my jokes on you guys.
So there's no more jokes. There's the whole entire prep.
Right. No more jokes. So don't get your hopes up.
Wait.
If I have 0.73 moles of lithium, how many atoms of lithium are in my sample? Okay, we're going to do the same system. We're going to do the same system that we did between grams and moles, like we're going to do with atoms and moles. But our conversion factor this time, we'll write it up here. Our conversion factor between atoms and moles or backward equals Avogadro's number. Okay. I want you to understand here. Actually, I'll give you just a second. I want you to understand the difference between an atom and a molecule. Right? Here's lithium by itself. That's an atom. Lithium chloride is a molecule. Okay, so when we say how many molecules are in a mole, it's still 6.02 times 10 to the 23rd, but that means there's that many of that bonded item. Right? Does that make sense? Okay, so when we use atoms and molecule, they use interchangeably in these problems, but we only use atoms when we're talking about a single element. We use molecules if we're talking about a compound. Okay? All right, so let's get back to our problem here. We always start with what we know. So I have 0.73 moles of lithium. I need to get rid of moles of lithium. And what do I want to go to? Nope. Atoms. I want to go to atoms. I can do that in one step because I have the conversion factor for that. I have the conversion factor between moles and atoms. Do I need to use molar mass anywhere here? No, right? It didn't ask for mass anywhere in the problem. It didn't ask for grams anywhere. I don't need to use molar mass. I'm just going to use Avogadro's number. So, moles always gets the 1. That's still true here. How many atoms do we know are in 1 mole of anything? Right, 6.022 times 10 to the 23rd. Okay, we know that many atoms is in 1 mole of anything, regardless of what element it is. It's that number. Okay, so we're going to plug this into our calculator. Are we going to get a big number or a small number? We should get a big number times 10 to the 20-something, right? Should it be less than Avogadro's number or more than Avogadro's number? Less than. We started with less than 1 mole. Okay, so here we go. 0.72 times 6 times 0.02 times 10 to the 23rd. I got 4.34 times 10 to the 23rd atoms.
I think you put 0.72 instead of 0.73.
Oh, you're right, I did. Thank you. My bad. 4.39. There we go. Easy fix. 4.396 could round up to 4.4. That's fine. 4.39 times 10 to the 23rd atoms of lithium. If you need help with your calculator, now would be the time. If I count it out, 8.23 times 10 to the 23rd grades of sand, I have no life, number 1, but how many moles of sand would that be? Do we need to know the molar mass of sand? Nope. Sand is not even on the period.
Loser.
That's why I count ranks are so weird, because people like to engage in the series.
Really awkward.
Are you in Parker the only sophomore? Are you in Parker the only sophomore?
What?
Can I just do it like this?
You could, since they have the same network.
Yeah, I can do it actually.
I'm like too, like, I like doubt myself too much with math to do that. Like, I would plug it all in, but that's fine.
Probably score for those. Bless you. Bless you.
Nope. With grains of sand. Okay, grains, whatever. What do I want to get rid of? I want to get rid of sand, right? Grains of sand. And I want to go to moles. Moles of sand. How many? What does moles always get?
0.
No. Moles always gets the 1. How many grains of sand are in 1 mole of sand? 6.022 times 10 to the 23rd. Right. It's just, right. It's just, a mole is 6.022 times 10 to the 23rd of anything. Right? It's that many individual of anything. Okay? This is where I want you to be good about using the E button so you don't have to use parentheses.
The problem with what I did, I was like putting it back in, and I was like 1.366 times 10 to the
Oh, right.
All you have to do is 8.23 divided by.
In this case, yes, you could have just done 8.23 divided by 6.02 because it's the same times 10 to the whatever, right? In that case. Not all problems would be like that, but you're right. In that case, you could have just done 8.2 something divided by that. So, 3.66 moles of sand. Now we need to check, does our answer make sense? Is it reasonable? Did you start with a number greater than Avogadro's number? Yes, our starting number is greater than Avogadro's number, so it should make sense that our answer is greater than 1 mole. Okay, so I want you to be checking yourself as you go through this. A couple other things that you need to think about. When I'm solving for moles, it should be a relatively small number. Usually moles fall between 0 and like 10, right? 10 moles of a substance is a lot. So when we're solving for number of moles, we should get a very reasonable number. When we're solving for the number of atoms or molecules or whatever, what kind of number should we get? If we're solving for the number of atoms of something or atoms or molecules, it should be huge, right? Because we're multiplying by Avogadro's number. So times 10 to the 20 something. Grams will fall somewhere in between. Grams can be all over the place, okay? But moles should be a small number. Grams somewhere in the middle. Atoms or molecules should be huge numbers, okay? So now we're going to look at how we connect all three. How can we go from grams to atoms or vice versa, okay? By using molar mass and Avogadro's number, we can convert between the number of grams of a substance all the way to find out the number of atoms in that sample. So I want you to think about this little question I posed up here, and I'll come back in about 30 seconds. What's going to be our middleman between grams and atoms, or grams and molecules? What's our middleman going to be? Moles. Good. Moles has to be our middleman. Okay? We don't know how many grams are in 4.8 times 10 to the 22nd atoms. Like, we just don't know that. That's not something that we know right off the bat. Okay? But we can convert to moles in between. And so our chart is going to add a step to it. And moles is going to be our middleman. Okay? So we're going to use our same conversion format. Our T-chart's just going to have 3 spaces instead of 2 as in our last problems. Let's try this one. How many salt molecules are in 14.52 grams of salt?
Is it important that salt, since salt is technically on the periodic table?
Well, NaCl is not on the periodic table as one.
Okay.
NaCl is a compound, so we're going to have to find the molar mass
Yeah.
for that.
Okay.
Okay? I just wrote salt instead of writing NaCl, right? I could have just wrote it out there too. That's fine. All right, so I always start with what I know. My goal is to get to molecules. Okay, 14.52 grams of NaCl. And I draw my T. Now I need to get rid of grams. Can I go directly to molecules? Do I know how many grams are in a molecule? Or do I know how many molecules are in a gram? No, right? I can't do that. So I can go to moles. Okay. Moles gets the 1. What goes with molar? What goes with grams always? What always goes with gram? Molar mass. Okay, we've calculated the molar mass of NaCl on a previous problem, but it's 58.5. Okay, and so I've canceled grams. Right now I'm in moles. Is that where I want to stop? No. So I need to draw another section to my T-chart, and I need to get rid of moles. And I want to end up in molecules. Molecules of NaCl. 58.5 is our molar mass, right? So moles, between moles and molecules gets the 6.022 times 10 to the 23rd, and moles always gets the 1. What? Moles always gets the 1, no matter what. Okay, so in this portion of our T-chart, we always make each section, individual section, true. 1 mole is always that many molecules, and 1 mole of salt always weighs that many grams. Right? You're making the column of your T-chart true. So moles has been canceled, grams has been canceled. Now we do the math.
Is there an abbreviation for molecules?
No, not really, and you can't like do MOLE because then it just looks like moles. You could stop it after the C if you really wanted to. Molec, that's fine. Should you be expecting a big number here or a small number?
Big.
It should be a huge, huge number. Huge number. 14.52 times Avogadro's number divided by 58.5. 1.49 times 10 to the 23rd is not a small number. Right? 1.49 times 10 to the 23rd, that is a huge number. There's 23 zeros that follow. 21 zeros follow that 9. It's a big number. Okay, so we need to understand that E23, do not leave that off, right? That means times 10 to the 23rd in your calculator. Okay. Questions about how we set up that chart? This is a super important concept for us moving forward. So if you have questions about how we're getting numbers or anything like that, now would be the time. Okay, one last thing. Yeah, sorry, Patrick.
So I got 1.51. Is that?
Yeah, perfect. Yep, fine. Yep. Okay. I don't take anything out of my calculator. I use the answer button a lot, so that's how I don't have to round anything. I just like to keep it as one problem. But if you take things out and put them back in, that's fine too. Last thing, the way we can abbreviate Avogadro's number is like this, N sub A. That means Avogadro's number. So if you're in the middle of your T-chart and you don't want to write out all of Avogadro's number, you could just put in this section of my T-chart, you can really just say NA, and I'll know you're talking about Avogadro's number there. You just got to remember to plug it in. Okay? Okay.
That looks kind of like sodium.
Try that one on your own. How many grams are in 6.244 times 10 to the 23rd molecules of sodium hydroxide?
41.5.
I got 40.
All right. Let's write it out because I think we were still having a little trouble. Okay, here we go. 6.244 times 10 to the 23rd. I'm not going to write out the units. Avogadro's number has to go on the bottom because I know molecules needs to be canceled. Moles goes here. It always gets the 1. I still need to cancel moles. It gets the 1. Sodium hydroxide weighs 40 grams, I think. So if I go... $41.47. Andy? I don't really think you'd want people to talk to you that way.
I actually don't care.
Well, I don't care. I don't want you to recommend that. Yeah, you have it set up, right?
Yeah, me too.
Okay, here's the problem. When you're not using the calculator, you're dividing by
Oh my gosh.
Wait,
I knew that's what
I got 1.56 times 10 to the 23rd.
Can we joke say that?
Though I'm only off by about 4
You could just do, no, the slippers and cones are 6.2.
Okay, you're going to do the next one on your own. I will answer questions about this as I walk around. Try that one on your own. 2.035 times 10 to the what? 2.03 times 10 to the 24th. How many of you agree? Are we close enough? Like, are we in the ballpark?
No.
What questions do we have about how we put it into the chart or how we use the calculator for Avagadro's number? Are you feeling pretty good about that? Okay.
Wait, there's a shortcut calculator.